Hello students, welcome to my lecture. Today we will be discussing about Taylor series expansion of a function. Okay, Taylor series expansion of a function of two variables. Yes. So Taylor series for functions of two variables. So you can read here, if f of xy and all its partial derivatives up to nth order are finite and continuous for all points x comma y, then its Taylor series expansion about a point a comma b is, you can see here, f of xy equal to f of ab plus x minus a into dou by dou x plus y minus b into dou by dou y of f of ab plus 1 by 2 factorial x minus a dou by dou x plus y minus b dou by dou y whole square of f of ab plus 1 by 3 factorial x minus a dou by dou x plus y minus b dou by dou y whole cube of f of ab plus etc. It will continue. Or we can write it in a different form. That means this one. This is a plus b the whole square form, right? X minus a dou by dou x plus y minus b dou by dou y the whole square. A plus b the whole square. If you expand this a plus b the whole square, you can expand it using a square plus 2ab plus b square. Similarly, this is a plus b the whole cube form. X minus a dou by dou x plus y minus b dou by dou y the whole cube. A plus b the whole cube form. Okay, a plus b the whole cube. We know that a cube plus b cube plus 3a square b plus 3ab square. Okay, so if we expand such brackets here, we can see this one. Okay, it will be available in this form. F of xy equal to f of ab plus x minus a into dou by dou x of f of ab plus y minus b dou by dou y of f of ab. Okay, here first one is same only, f of ab here, f of ab. Next, here I open this bracket. That means this f of ab I took inside. So x minus a dou by dou x of f of ab. That's what you can see here. X minus a dou by dou x of f of ab plus y minus b dou by dou y of f of ab. That also you can see. Okay. Plus 1 by 2 factorial. That also I am repeating. 1 by 2 factorial. See, this is a plus b the whole square. A square plus 2ab plus b square. A square becomes what square of this? So x minus a the whole square. That x minus a the whole square you can see here. Then dou by dou x, its square becomes dou square by dou x square. Okay, dou square by dou x. And f of ab will be here. This f of ab, if you take inside, that you can see there. Okay, f of ab plus 2ab, a square plus 2ab, right? So 2ab means 2 into x minus a into dou by dou x into y minus b into dou by dou y, 2ab of f of ab. That's what you can see here. 2x minus a, y minus b, and that dou by dou x and dou by dou y becomes dou square by dou x dou y. And this f of ab will come from outside the bracket. Okay, this f of ab will be here. Plus b square. B square means y minus b the whole square. Y minus b the whole square you can see. And the square of dou by dou y. That means dou square by dou y square. And with that f of ab that was outside here. Okay, plus etc. It will continue. This also you can expand using a plus b the whole cube formula. Okay, yes. So this is a Taylor expansion for a function of two variables. Okay, now let's apply this, or let's solve one question based on this. We have a question. See this question. Expand e raised to x log 1 plus y in Taylor series around origin in terms of second degree. Okay, that means we are given with a function here, a two variable function in x and y, f of xy. Okay, e raised to x log 1 plus y. Okay, so what is our f of xy here? F of xy equal to e raised to x log 1 plus y. That is our two variable function here. Okay, and they are asking about origin. So our AB, okay, this is the Taylor series expansion about a point AB, about a point AB. Okay, but in the question they are asking about origin. So here AB is what? Origin 0, 0. Okay, so what will happen to our Taylor series expansion? See, first here we have f of xy. Instead of this f of xy, what we can write? E raised to x log 1 plus y. So that f of xy becomes e raised to x log 1 plus y. I am substituting here. This f of xy becomes e raised to x log 1 plus y. Okay, equal to. Next we have f of ab. So that f of ab becomes f of 0, 0 because ab is 0, 0 here. Okay, like that I am doing all the substitution. this x minus a becomes x minus 0, and dou by dou x of f of ab becomes dou by dou x of f of 0, 0, plus y minus b becomes y minus 0 because b is also 0 here. Then dou by dou y of f of ab becomes dou by dou y of f of 0, 0. Okay, plus 1 by, okay, this 1 by 2 factorial becomes 1 by 2 because 2 factorial is 2 into x minus a the whole square. Again, that x minus a becomes x minus 0 the whole square. Then dou square by dou x square of f of ab. So dou square by dou x square of f of 0, 0. ab becomes 0, 0 plus 2. Okay, all the substitution. X minus a into y minus b becomes x minus 0, y minus 0. Then dou square f of ab by dou x dou y. So that becomes dou square f of 0, 0 by dou x dou y plus y minus b the whole square, y minus 0 the whole square, dou square f of ab becomes dou square f of 0. Okay, same, etc. Now let's find each of the values. First find f of 0, 0. Okay, what is f of 0, 0? This is f of xy, e raised to x log 1 plus y. So to get f of 0, 0, put 0 for x and 0 for y here. So this will happen here. E raised to x becomes e raised to 0 into log 1 plus 0, 1 plus y becomes 1 plus 0. Okay, we know that log 1 plus 0 is log 1 only, log 1 is 0. 0 into anything means 0 only. So the result is 0. F of 0, 0 is nothing but 0. Okay, then what is dou f by dou x? That is the partial derivative of f with respect to x. Okay, so in that case, this is our f of xy. We are differentiating with respect to x. So log 1 plus y will be constant. That you can keep separated, log 1 plus y. Then you can take the derivative of this e raised to x. Derivative of e raised to x is e raised to x only. So you'll get same e raised to x log 1 plus y. Same function only. Okay. Now they are asking the value. Here we need to find the value dou by dou x of f of dou x by dou x at 0, 0. That means, yes, here we got dou x by dou x. At 0, 0 means you have to put values 0 for x and y here. Okay, so dou by dou x of f at 0, 0 becomes what? This e raised to x becomes e raised to 0 and log 1 plus y becomes log 1 plus 0. Okay, so again the same thing will happen. This we got already 0. So this is nothing but 0 only. Okay, next find the second derivative. Second partial derivative of f with respect to x. Dou square f by dou x square. Second partial derivative means what? We're differentiating 2 times. Okay, already we differentiated once here. So dou f by dou x becomes e raised to x log 1 plus y. This again we have to differentiate with respect to x. That's what you can see here. Sorry, this is not d by dx, this is dou by dou x. We are doing partial derivative, not d by dx, dou by dou x. Dou by dou x. That means we are differentiating with respect to x again. Once we differentiated, we got the same value, same function, e raised to x log 1 plus y. E raised to x log 1 plus. So differentiate it again. What will happen? You will again get the same. Okay. So log 1 plus y is constant. You can keep it separated. E raised to x derivative is e raised to x only. Okay. Now you can find this dou square f by dou x square value at 0, 0. So put x 0 and y 0. So e raised to x becomes e raised to 0. Log 1 plus y becomes log 1 plus 0. Okay. Log 1 is 0, 0 only. Okay, so dou square f by dou x square is also 0. Now let's find dou f by dou y. Dou f by dou y. With a partial differentiate it with respect to y. Okay, so that x becomes e raised to x becomes constant here. E raised to x becomes constant, and the derivative of log 1 plus y is 1 by 1 plus y. So the derivative becomes e raised to x by 1 plus y. E raised to x is constant, derivative of log 1 plus y 1 by 1 plus y. So e raised to x by 1 plus y. Okay. Okay, now what about the value at 0, 0? We need the value at 0, 0 of dou f by dou y. So x and y becomes 0, e raised to 0 by 1 plus y becomes 1 plus 0. E raised to 0 is 1 only, 1 plus 0 is only 1, 1 plus 0 is 1 itself. So 1 by 1 is equal to 1 only. Okay, now do the second derivative. Differentiate it again. That means dou square f by dou y square. Dou f by dou y we already got. That is e raised to x by 1 plus y. So second derivative means differentiate it with respect to y again. So dou by dou y of e raised to x by 1 plus y. Okay. So here also you can take e raised to x as constant, and derivative of 1 by 1 plus y becomes minus 1 by 1 plus y the whole square. Derivative of 1 by y is minus 1 by y square, right? Like that. So now let's find the value at 0, 0. So put x as 0 and y as 0. So minus e raised to x becomes minus e raised to 0. By 1 plus y becomes 1 plus 0 the whole square. So minus e raised to 0 means minus 1. By 1 plus 0, 1 only. So minus 1. Okay. Next, let's find dou square f by dou x dou y. That also we need here. Here we need dou square f by dou x dou y. Okay. Dou square f by dou x dou y. Let's find it. So that means what? First, you have to differentiate it with respect to x. Then you have to differentiate with respect to y. Okay. So dou by dou x. First, if you differentiate with respect to x, you will get the same function. Okay. Dou f by dou x is what? Same function only. Okay. E raised to x log 1 plus y. Then again with respect to y. So again differentiate this with respect to y. Okay. So partial derivative of e raised to x log 1 plus y. Okay. With respect to y becomes what? This already we got, right? Okay. Derivative of this function f with respect to y we already got as this one. Okay. So e raised to x by 1 plus y. Okay. So the derivative of this with respect to y becomes e raised to x by 1 plus y. Now at the point 0, 0 means e raised to 0 by 1 plus 0, that is 1 only. Okay. Now we got all the values. Okay. We got all the values. F of 0, 0 we got. F dou f by dou x at 0, 0 we got. Dou square f by dou x square at 0, 0 we got. Okay. Dou f by dou y we got at 0, 0. Dou square f by dou y square at 0, 0 we got. Okay. Dou square f by dou x dou y, everything we got now. Okay. Let's just substitute these values in this equation number 1. Okay. Substitute these values in equation number 1. So what will happen here? E raised to x log 1 plus y equal to e raised to x log 1 plus y equal to, first we had this f of 0, 0. What is f of 0, 0? 0 only. 0 plus, next we had what? X minus 0 becomes x only into dou by dou x of f of 0. Dou by dou x of f of 0 we already got. Dou by dou x of f of 0, 0 is 0 only. Okay. So x minus 0 means x of x into 0. Okay. That's what you can see, x into 0 plus y minus 0. Y minus 0 is 1 only. Sorry, y only. Okay. That y is what you can see here. Y into what? Into dou f by dou y at 0, 0. Dou f by dou y at 0, 0 is what? That also we have got here 1. So that means y into 1. Okay. Then after that what we have? Plus 1 by 2. Plus 1 by 2. This x minus 0 the whole square becomes x square. That's what you can see here. 1 by 2 x square into what? Dou square f by dou x square at 0, 0. What is the value? We got the value that is 0 only. Okay. So that becomes x square into 0 plus 2x minus 0 into y minus 0 becomes 2xy. And dou square f by dou x dou y is what? At 0, 0. Dou square f by dou x dou y at 0, 0 we got. That is also 1. So this becomes 2xy into 1. Okay. Plus y minus 0 the whole square becomes y square only. Okay. That y square is what you can see here into dou square f by dou y square at 0, 0. That value also we know that is minus 1. Okay. So that minus 1 you can give plus etc. Okay. That means e raised to x log 1 plus y equal to, this becomes 0, this becomes 0. Okay, y into 1 is 1 only, 1 by 2 is here. This becomes 0. 2xy into 1 means 2xy only minus, plus y square into minus 1 means minus y square. Okay, so that means e raised to x log 1 plus y equal to y plus, open the bracket. So 2xy by 2 becomes, here y also will come. Okay, 2xy by 2 becomes xy. Okay, not x only, xy, sorry. Minus y square by 2. Okay. So this is the answer. Okay. I hope it's clear for you. Thanks for watching. See you in the next video. Okay.